My name is Kelly Smith. This is my informative speech on DNA evidence. Today's date is October 5th, 2019. How many of you have been kept up late at night watching shows like CSI, Cold Case Files, and Law and Order? I think all of us have. The nature of these shows is pretty insomnia-inducing, not so much for the content, but because of our fascination with how the investigators piece together the evidence like pieces of a puzzle. One of the most critical pieces of evidence that these investigators use in these cases is DNA evidence. It's a fairly new technology, which is not known to many people, only 35 years old, according to the Gale Encyclopedia of American Law. The various developments in testing have been crucial to solving these crimes. In my time with you today, I'd like to discuss a brief history of DNA evidence, some different types of DNA analysis, and how DNA data is currently stored. So, DNA evidence was first proposed by Alec Jeffreys, a British geneticist, in 1985. So, like I said, it's a fairly new technology. An excerpt from Truth Machine, The Contentious History of DNA Fingerprinting by Michael Lynch indicates that DNA evidence was initially widely accepted, but soon fell under scrutiny because of poorly executed techniques and unreliable reporting of statistics. The credibility was assessed from both a scientific and a judicial perspective over the next 10 years, and it became widely accepted again in the late 90s, as long as proper analysis was performed and there was an accurate reporting of the statistics. So to allow you to better understand DNA evidence and how DNA analysis works, I will describe a few processes used to find a DNA match. The first type is called mtDNA profiling. Also, that's short for mitochondrial DNA. So I'd like to show you a little graphic here that will kind of explain this a little better. This is a cell, just a typical any human cell. The nucleus is here. Now that is where we normally would like to get DNA. That contains the 46 chromosome DNA that is your entire genetic genome. But we do have the mitochondria, which is known as the powerhouse of the cell. That's where energy is created in the cell. And there are smaller ring-like structures of DNA contained in mitochondria. This DNA is identical between siblings. It is inherited from the mother, and it's useful in degraded samples or skeletal remains because there's typically more mitochondrial DNA able to be found there because the nucleus only contains 2 DNA strands per cell, whereas there could be thousands of those small ring-like structures of DNA in a mitochondria. So the next type I'd like to talk about is called YSTR profiling. This type of analysis is performed a lot of times in sexual assault cases because they can use it to separate DNA of male and female, because males have an XY chromosome, females have XX. It can also be used to separate 2 different males' DNA. According to John Butler in Advanced Topics on Forensic DNA, the results in these tests is not as valuable as results from nuclear DNA, but it can be useful when combined with other evidence to narrow the scope of suspects. The last type I'd like to talk about is familial searching. A lot of people are familiar with this. It's used in missing persons cases and stuff like that. Even a partial match on this nuclear DNA from the nucleus indicates a very strong match from family member to family member. It's especially useful in criminal cases, and the family DNA can be volunteered or it may already be stored in the database. So now that we've had a brief history of DNA analysis and discuss some of the types of analysis, we will discuss how this massive amount of info that we obtain is actually stored. So DNA is stored in databases. The very first database for DNA was during Desert Storm in 1991. They wanted to get DNA profiles together so that they could identify fallen soldiers. The next DNA database after that is called the NDNAD. It's the oldest and the largest national DNA database in the United Kingdom, and it was formed in 1995. And then we have CODIS, which you may be familiar with. I've mentioned it before in shows like Law and Order and Cold Case Files. That stands for the Combined DNA Identification System. That's our U.S. database. And this database includes DNA from crime scenes, from prisoners, from voluntary samples, and also from unidentified remains that are found. So in conclusion, although this is a very new discovery in forensics, it's a pivotal part of criminal investigations. It's even helped exonerate prisoners who were falsely convicted of crimes. The goal with DNA analysis is to calculate a statistical match to prove guilt or innocence, either way. And to increase the odds of a match, we store all of this information in databases, and then it can be used in the future, several years in advance. So hopefully you'll keep all this in mind next time you're wide awake in the middle of the night watching your true crime shows.